Radiation is the transfer of energy in packets called photons. Nothing is actually physically transferred, yet one object can affect another some distance away. As this radiation travels, it can be reflected like the light hitting the mirror here. Or it can be absorbed like in this leaf where it might be used for photosynthesis. Or it can be transmitted, as you can see as this light travels through the window. Or finally, it might be a combination of all three of these things. The object emitting or giving out the radiation is known as the source, and in this case it's the sun. But it could be a range of different sources such as radio masts, microwaves or TV remotes. As you get further from the source, the strength of the radiation, or the intensity, decreases. This is because the light becomes more spread out over a larger surface area, and some of it is partially absorbed by the air that it's travelling through. The sun is a source of radiation in the form of light. However, this is only part of the radiation that the sun produces and sends to Earth. There are many other forms of radiation that we cannot see, and they are radio waves, microwaves, infrared, visible light, ultraviolet, X-rays and gamma rays. The order they're placed in here is extremely important, as they're arranged in order of increasing frequency, all the way up to gamma rays with the shortest wavelength. Despite their differences, these different forms of radiation are grouped together in the electromagnetic spectrum, and they all share the same finite speed in a vacuum, such as space, of 300,000 kilometers a second. The radiation with the high frequency, gamma rays, X-rays and UV rays, are extremely dangerous. This is because they have lots and lots of energy, and they can use this to knock off electrons from atoms and change them. This process is known as ionisation, and these cells can go on to cause chemical reactions, which can be dangerous. The sun also produces lots of harmful radiation, and prolonged exposure to it can lead to problems such as cell death and cancer. Luckily for us, the Earth offers its own protection through the ozone layer, which stops most of the harmful UV radiation from getting to us. Any that does, we can reduce its effect by wearing sun creams or by minimising our exposure to sunlight. If you've ever had an X-ray, you might notice that the nurse might be wearing a lead apron. This stops the nurse from receiving the harmful effects of the X-rays, which she's doing repeatedly day after day. Right, let's go back to the Earth's atmosphere because it's really important. Radiation from the sun is going to enter into the Earth. Some of that radiation is going to absorb, causing the Earth to warm up. But other belts of it are going to get reflected back, and some of this will go off into space. However, some of that radiation is going to get reflected back into the Earth. This is going to cause the Earth to warm up, and this is known as the greenhouse effect and can lead to global warming. The main greenhouse gases are carbon dioxide, water vapour and methane. Both carbon dioxide and methane are found in very tiny amounts in the atmosphere, but they cause a big difference in the climate. Humans are really affecting this system through deforestation and the burning of fossil fuels. Deforestation, where forest land is cut down or burnt to make way for farmland, has a really negative impact because it stops the trees photosynthesising and taking in carbon dioxide from the atmosphere. The burning of fossil fuels, on the other hand, for energy mainly, releases lots of carbon dioxide into the atmosphere. Other processes, such as respiration, also release carbon dioxide into the air. Ultimately, climate change is going to mean it's impossible to grow crops in certain areas of the world where we used to, due to the change in the climate. It's also going to lead to more extreme weather events, due to the large amounts of convection and the increasing water vapour in the air. Low-lying regions will also become much more vulnerable to flooding, due to the expansion of the water and the melting of continental ice. Now, we've talked about our high-intensity radiation and how they can be interesting and dangerous, the ultraviolet X-rays and gamma rays, but it doesn't mean that the low-intensity end of the spectrum is any less interesting. Microwaves are strongly absorbed by water molecules, and they cause them to move and vibrate and heat up. People are very interested in the effects this could have on the human body, because things like mobile phones use microwaves for communication, and obviously we hold them close to our heads. This doesn't mean that you should try and avoid your microwave though. They're designed to be safe. The metal doors and screens are designed to reflect the microwave radiation or absorb it and keep it within the microwave to stop it penetrating your body. The rest of the electromagnetic spectrum we can use for communication. Light and infrared are often used in optical fibres because they can transmit information a long way without being absorbed by the glass. Radio waves are obviously also used for communication over really long distances. There are two main types of radio waves, analog waves and digital waves. In both waves we have to superimpose the information onto a carrier wave to send it from the source to where it's going to be received. Analog waves vary continuously. This means they can take on any number, whereas digital waves look more like tower blocks. They only take on a couple of discrete values, usually 0 or 1. Digital waves are really good because you can easily remove noise from the signal. They're also able to be processed and used by computers.